So next thing, so this is my major emphasis in hazardous waste management choices. And the clear way to deal with them is reduce, reuse, and recycle, right? And the last resort is bury them in the landfill or burn them. Last, I want to quickly go over the toxic chemical releases. About 1.6 billion kilograms of toxic chemicals reported released. That's a lot into the environment by industry. So industry is the main source of those hazardous waste, as we can see. And the primary are mining, power generation, chemical and metal manufacturing. So we can see in this pie, metal mining, that is responsible for almost half of the hazardous waste in the whole thing. And the second one is electric utilities. Other players are metal manufacturing, chemical, and the third group is all the miscellaneous and hazardous waste management. So those responsible for another like 25% of the whole thing. So major player are metal mining, electric, and primary metals, and the chemicals. From this graph, we can see zinc compounds, lead compounds, nitrate compounds contribute the most to this list. And comparing all the different states about 80 years ago, Alaska is surprisingly the highest state, and then Nevada, Texas, we generate a lot of hazardous waste also, and then Utah, Louisiana, Indiana, Illinois, those are middle, north, and Arizona. So majorly the waste was disposed mainly, this is toxic releases dominated by mining and electric generation. So those states you can see have the highest waste resulting from the mining and electric city generation. Last thing I want to mention really quick is a nuclear waste disposal. Just give you an overview, okay? So DOE has become steward of a large number of sites. This is very interesting. This is not OSHA or EPA, but Department of Energy that become in charge of disposing the nuclear waste. And contamination majorly comes from nuclear research and weapons production, mainly during World War II. And if you are interested in any of the details, you can pause the video so you can read all those details. So, but overall, this is general. I know people are curious, right? How much we generate, where those waste go. So I want to give you an overall picture, but I don't require you to remember those technical details. And DOE's responsibility. A large number of these sites contaminated, over 500 sites we evaluated, and over 100 sites required some level of cleanup. And you can see the contaminated nuclear sites remaining. Glad Texas is not one of them. So those heavy sites in Washington State, right? Idaho, California, Nevada, Utah, New Mexico, and others on the east side of New York State, New Jersey, Kentucky, Ohio, Tennessee, and South Carolina. Transuranic waste disposal, that is from former nuclear weapons site, that is transported to Nevada. This facility began accepting waste in March 1999. That's about the time I come to United States. Probably a lot of people were born around that time. So at the time you were born, we opened the site in, it's not Nevada, it's New Mexico. I'm sorry, New Mexico. So that site is accepting all those transuranic waste. Just quick look. How we isolate the waste and store them. We bury them deep, those nuclear waste, in those compartments. This is experimental area. This is very deep, underground, 3,000 feet. 3,000 feet, that's about 100 meters, that's about 1 kilometer. So this is where the sites are, deep under the ground. And uranium mining and the mining waste, the waste management activities include building fences, putting up warning signs that establish land use restrictions, and covering the waste with a thick layer of soil and rock to prevent erosion, windblow particles, and groundwater contamination. And we have a, let me see, where is it in the textbook? We have an article about cleaning the contaminated groundwater. That is page 458. That's the Hanford facility, a storehouse of nuclear remains. I want to read to you really quick. Contaminated groundwater is being pumped and treated at a rate about 750 million liters per month. By 2016, about 50 billion liters of groundwater had been treated. So if those facilities have problems, this is what we suffer from. And for the high-level radioactive waste disposal, well, that is a major problem for the nuclear power industry. There's no permanent storage facility, and many plants are running out of temporary storage, and most experts feel the best solution is to bury waste in a stable geologic formation. And this is 2 examples how they store those wastes. One is underwater, and the other is in those very secure containers which prevent radiation. And for the low-level radioactive waste disposal, 1986 was a deadline for each state providing its own storage sites. And primarily it's buried in South Carolina, Washington, and Utah, but later on every state is responsible for the low-level radioactive waste disposal. And if we look at this map, this is the low-level radioactive waste site. We have Texas, accepts waste from Texas and Vermont. We have South Carolina that accept waste from Connecticut, New Jersey. So this is a map that those are the previous radioactive waste site, but after 1986, every state is required to provide their own storage site. So this is concluding my chapter 19, and I generally overview the laws, right, the methods, and the definitions of the hazard waste management. My focus is still, guys, ponder on 3R, reduce, reuse, and recycle.